Hi, I'm Alex. I'm a software developer with VitalSim, and in this video I'm going to be giving an introduction to our main product, which is a desktop software application for simulating and testing vital logic. So if you're watching this video, you probably know what vital logic is, but basically it's the critical or fail-safe logic used in railway signaling. Okay, so let's get right into it. Here we have 6 files, and these files are outputs from a vital logic design application. So if you're a railway signal engineer, you're probably already familiar with these file formats, but let's take a look inside them just as a quick refresher. So here we have a report file, and the contents of that are here. So basically this will tell you what type of controller this program runs on. It will tell you how the auxiliary modules are configured. So you have I/O modules, serial port modules, things like that. It will tell you which timers you have in your program and how they're configured, and the tags or variable names in your program. Okay, so actually one other thing, we also have the equation files. So that's these guys. And that will actually define the ladder logic running in your program. So here's an expression of some ladder logic, and here's the tag names associated with that. Okay, so in this project we have 6 files, and that's because there's 2 controllers. And in this project, the 2 controllers represent the east and west sides of an end of siding location. So we have similar, they're symmetrical, the east and west sides, and so the variables are going to basically be the same in both controllers, and the ladder logic is going to be basically the same as well. So in our software, when you choose one file, it's going to look for all the files next to it in the same folder, so it doesn't really matter which of these we choose. All right, so let's just go ahead and open this one up. Okay, so this is the first view I want to introduce. This is the app navigator, and basically this is a direct view into the logical values, the state space of your running application. So you can see here in the middle you have tag names or variables. Over here on the right you have the values of I/O, and here on the left you have timers. So you can tell whether a timer's input is triggered, whether the output is triggered, and how long that timer takes to trigger. So you can see that all the tags here are either green or white. That indicates the logical state. So green tells you that that value is picked or true. White indicates that that value is dropped or false. Okay, so the second view in our application is the track plan, and this is kind of a geometric or schematic symbolic representation of what's going on in the background of your program here. So this is really just a thin graphical layer to make it more intuitive for debugging and testing. Alright, so there's a lot of stuff going on here, and this is actually being set up in advance. So when you open a new program using our software, you don't get this out of the box. It's up to the user to choose which icons you're going to use, where you're going to position them, and how they're configured. So I'm not going to go into full detail in this video. There's a lot of different ways to configure this, a lot of different variables. But basically for each icon, you can right-click it, and you get a dialog that allows you to select which tags in your application dictate the rendering of that icon. So here we have a switch, and in a program that has switches in it, you're probably going to have some tag values associated with I/O for that switch, maybe a command going to that switch, or an input to your controller from the switch. So this dialog will allow you to configure those tags. You can see here we have other things like we have signal lights, and you can consider how many lamps are presented with this light. Here we have a coded track, and here we have tag groups. So essentially these are just convenience icons that allow you a direct view right into the logical values in the background here. So instead of having to switch between these 2 windows, you can just configure tag groups and see everything through here. Okay, so right now we're in edit mode, and this mode is intended to allow the user to add or delete icons, to change the tag mappings to the icons, things like that. But when you want to actually begin interacting with the logic in your application, you're going to want to go into test mode. And now you'll see that when you hover over an icon, you can get a pop-up showing you the logical values in the background here. Okay, so when you start testing, the first thing you're going to want to do is normalize the application. And what that means is to reset or bring all of your tag values, timers, and I/O to a known state so that your test is well defined. So I'm going to select both controllers for normalization here and start that. And while we're at it, I'll just mention that this particular project is running two controllers of the same brand. They're both Electrologics, but our application can equally well simulate a project that has controllers of different brands in it. Okay, so now that that is done, we can actually begin interacting with the application logic and performing some tests. So it's possible to perform tests through this interface here, kind of graphically or schematically, if you know how the site is laid out. But in this case, I want to go back to the app navigator over here so we can actually inspect the logical equations running in our controllers. So let's just take this variable, for example, this tag 1LR. And if we right-click that, we get a view of the ladder logic that's used to calculate this variable in our controller. Okay, so we can see that the tag 1LR is calculated using the equation 2NSR and 2SSR and 2TPER. And the result of those ANDing these three tag values is 1LR. Okay, so suppose part of our validation requires us to cause this variable to drop or to become false. Okay, so what we can do there is we can recursively inspect this equation and see what values are used to calculate this tag, for example. So this is a timer, 2TPER, and currently it's triggered. So it's picked or true. So if we right-click that, we can see the logic that's used to trigger that timer. So the input to this timer is 2TPR, and it takes 15 seconds to trigger. So timers are simulated as being triggered after a threshold, but becoming dropped instantly. So for example, if this variable goes from picked to dropped, the timer will instantly drop. Whereas if this variable goes from dropped to picked, the timer will take 15 seconds to become picked. Okay, so going back to where we were a moment ago, what do we have to do to cause this variable to become dropped? All we have to do is drop this input variable on the I/O card over here, which will cause the timer to instantly drop, and then this output tag should drop. So let's just check that. So I'm going to click this tag value here, and because it's currently picked, it's going to flip the value on that, and it's going to become dropped or false, and then we should see 1LR become false as well. Okay, so that all works as we expected. We have the input to the timer here, which I flipped the value on. The output of the timer flipped. It's now dropped, and the equation here is true and false, which works out to false, so 1LR is dropped. Okay, so that worked the way we expected, and we can consider that a success. But in reality, you're probably going to want to perform more complex tests. So our application allows you to record all changes of state for your documentation. So for example, you don't just have to do a visual check that this variable here is dropped, you can get a report. Okay, so I hope that was helpful. There's a lot more things you can do with our software, but we're going to cover that in other videos. So if you have any questions, please feel free to leave us a comment below or email us. And if you enjoyed this video, remember to like and subscribe. Thank you.